Today we are planning to do one of the questions actually we get in lots of MCQ papers. Actually almost all the MCQ papers actually we can see this question. The question, it is from humidity heat question. You must have tried those questions now. Maybe it's a difficult question. Some of the students actually it's a really difficult questions, but if you have found the right pattern for it, you are now doing that question. I'm pretty sure with that, right? If you find this is a bit of a difficult question, let's see what are the points actually you should look at. So when we look at the questions that are given in our A levels, there are three types of questions I can see. So first question type is it's from graphs, the graph questions, and then actually we can see the questions from statements. So you should know certain level of theory to see through this question. So if you know a certain amount of theories, then you can get through it. And the last part is value questions. So you are given a certain value, maybe a numerical value, or some symbols are given. So the symbol questions actually that are the hardest question. Actually most students find it difficult. And let's see these question three types. I'll explain you one by one and I'll explain you couple of questions. Right, let's do it now.
Alright students, let's get into the humidity questions now. When it comes to the humidity, we have actually two types of humidity you can see: relative humidity and absolute humidity. Actually, the absolute humidity, you should know theories for that. Here actually I'm not explaining theories. Absolute theory means mass divided by volume, so it's a certain value. And again, relative humidity, actually that's a ratio multiplied by 100, right? So relative humidity, we actually get most of the questions from relative humidity, right? So for relative humidity, there are four types of equations. So you must have written in different format, but this is the format actually that is easier to remember. So first one, relative humidity means, so how do you find the relative humidity? Is mass, current vapor mass divided by saturated vapor mass, right? When the situation is saturated, so current vapor mass divided by saturated vapor mass into 100, we get the relative humidity. And the second one, actually it's from absolute humidity. So this here A mean absolute humidity, current absolute humidity. Now what is the situation? Divide by absolute humidity when saturated. So that multiplied by 100, we get relative humidity. Third one. So third one, current vapor pressure. Current vapor pressure divided by saturated vapor pressure, right? Saturated pressure, right? So when we get the ratio of these two and multiply by 100, we are getting relative humidity. Fourth one, it's from dew point actually. So absolute humidity at dew point divided by absolute humidity when the system is saturated into 100. I hope you know what is dew point. Dew point is, it's a temperature actually where the system is saturated with the existing amount of water vapor, right? So right, I hope you know dew point, right? So if you don't know these theories, actually go back to your theories and check them and come back doing questions. So if you have any problem doing relative humidity question, these are the reasons for that. If you don't know these things, that means you cannot do the question. Easy. Right, let's get into the question models that are available. Right, so first question model we have is the graph. So we are getting a graph to analyze. So we are getting a graph like this, so variations and all that. So absolute humidity, relative humidity graph. So we have to analyze that and we have to find the answer. And question number 2, it's actually from statements, right? So we get certain 5 statements. Out of those we have to find the correct answer, or true answer, right? Third method, actually it's from values. So we are given different values, maybe values from numerical values, or we'll be getting symbols, right? So symbol type questions, these are the hardest type, as students find it difficult anyway, right? Let's get into the question models now. First question model, graph questions, actually we get a variation of relative humidity. Say now here we have assume this is a closed system, and you can see there's a certain amount of water, small amount of water, small amount, remember the word small amount. So when the temperature is increased, what actually happens is these water actually that becomes vapor, right? Continuously vapor is forming, right? So what actually happens is absolute humidity, if initially there's a certain value, along with the temperature it will increase. So you can see that absolute humidity increase at a certain point. Once everything is evaporated or vaporized, done, no change in absolute humidity. So initially what actually happens is relative humidity will also along with absolute humidity it will increase like this. So up to a certain level you can see we have to assume the system is saturated. So relative humidity is increasing because water is there, but still when the temperature is increasing, relative humidity will not change up to a certain level, let's say, and then it will start decreasing, right? When the temperature increases, actually P over Ps or M over Ms, so this requirement will increase, but these value will not increase that much, right? So you should know how to analyze these graphs, right? Moving into third type. Actually in third types we are getting statement questions, so you will have to answer whether this is saturated or dew point related questions or saturated questions. Likewise you have to answer the statement that are given. For that actually you need to remember at least these equations, the connection between these, right? And also something like this, when vapor is present, actually most of the time the closed system it is saturated and relative humidity is 100% and all that, right? The last question type is value based question. So basically what actually happens is we are given the mass, initial mass of vapor, and they'll be telling you that a certain amount of vapor mass m goes out and the temperature is increased, and the couple of scenarios are given. Then you need to find relative humidity or certain dew point when the data is given. Likewise we'll be getting certain questions, right? So I'll give you some example questions, so from that you can understand the question types I'm giving. Right, moving into the graph type questions. So actually these are old physics papers, from old physics papers, MCQ question. So let's read the question. It's we are given a graph, so you can easily see that, right? Then the graph, let's read the question now. Actually if you can do the question before I give the answer, that's great. So hold the video and just do the question and come back for the answer. So let's do it now. The curve shows the variation of the absolute humidity H. So they are showing the absolute humidity, remember that, isolated volume. So it's actually separated of atmosphere with temperature theta, the relative humidity of a volume corresponding. So they are asking the variation of relative humidity, remember that, right? So you can easily see when the temperature is increased, the temperature is increasing now here, up to here temperature is increasing. So what basically happens is they are telling when temperature is increasing, absolute humidity is increasing. If this is isolated, the absolute humidity increases. That means the amount of water vapor present in air, the mass is increasing. So for that actually there has to be certain amount of water. So when temperatures increase, the water becomes vapor, right? So then only the absolute humidity increases. That is what you can see here in this way, right? It goes like that. And then after C, even though we increase the temperature, the absolute humidity becomes constant. That means no more water goes up. That means water is over, water layer is now has completely become, yes, vapor, right? Let's get into our answers now. Point A can be 100%. Of course you can see it's not, because when the temperatures increase and there's no more water vapor to come, so even the temperature is increasing now, so this is wrong. And the point B can be no, it's not. And point A and C can be the same, no, because relative humidity is not same at this point temperature and this point temperature. Temperatures are not equal. TA and TC are not equal, but absolute humidities are equal. So M divided by MS, you can see M is constant but MS is increasing, so it's not. And point C can be less than 100%. Point C can be less than 100%. Okay, let's hold it there. Final answer, point D can never be less than 100%. Yes, point D, that means still there's water vapor, still vapor is visible. So if vapor is visible, that means relative humidity is always 100% because the system is saturated, remember that. So fifth one is our answer, right? All right, moving into the second question from the graph, right? Let's read the question, and if you can do the question, yes, stop there, try the question and then come back. So now I'm moving into the answer, right? As shown in the figure, the temperature theta of air inside the closed room is varied. It's a closed room, remember that, it's a closed room, is varied with temperature according to curve A. So you can see this is the curve A. So temperature is decreasing and then, yes, constant and increasing. Its relative humidity is found to vary with time according to the curve B, right? So relative humidity actually it's increasing and constant and yes, like that. Okay, so they're asking us find the variation of absolute humidity. So let's investigate our question now. So when the temperature is decreasing, so let's write the equation M over Ms. The Ms requirement that actually goes down. So that means if the mass is constant, the relative humidity will increase. So you can see accordingly it is increasing. So we can assume there is no change in mass M, right? So it hits the dew point here, 100% relative humidity at this point, you can see that, right? That means we are at the saturated point. But look at the point here now, even it hits the dew point, but there's no change in temperature after that. So temperature is constant, right? Then again temperature is increasing. If only the temperature goes down, there will be a change with, yes, current vapor mass. So there's no change in current vapor mass, no change, right? And increasing. So that means absolute humidity, it won't change throughout the time. Mass is constant. So here the answer is fourth answer. Again, I'm telling you another point here. Remember that if temperature goes down beyond dew point, actually, then there will be a condensation of vapor. So it won't happen here. If only that happens, answer will be the third one, but here it's not happening. So answer is the fourth one, right? Now we are moving into statement type question. All right, first statement question. So you can hold there and find the answer, then come back of course for sure. So I'm moving into the answer now. Let's read the question. Large vessel of water is placed inside a closed room. So let's say we have a closed room and a large vessel with water is placed inside of it. Having a relative humidity is 50%. So it's not saturated. That means no saturation there, right? If the temperature remains constant as the time goes in, so temperature is constant, remember that. So M divided by Ms. If temperature is constant, remember that Ms, saturated vapor mass, is constant. So only M can change, right? First answer, absolute humidity inside the room will increase continuously. Yes, absolute humidity actually will increase. So this water becomes vapor slowly. That will happen until, yes, until the relative humidity becomes 100%, and after that no more vapor comes into the room. So that means the continuous part, so it's wrong. Relative humidity inside the room stays constant. Yes, after certain time it stays constant. It becomes 100%, then it is constant. So but still it will move from 50 to 100, so it's changing. C, the dew point of the room becomes equal to the room temperature of the above. Yes, exactly. slowly the relative humidity becomes 100%, the temperature it won't change. So when the relative humidity is 100%, that is dew point. So dew point and the current temperature both becomes equal. So final answer is C. So it's a second answer, only C is true. Right, let's move into the last question type now. Right, the last question type, actually the values are given, numerical values or symbol values are given. So here actually I'm picking question with symbols actually, so certain values are given. Right, so try these type of questions if you are not familiar these type of questions. If you get a question like this, because if you are not familiar you will skip the question, but if you have practiced these type of questions, there are plenty of questions you can find from past paper books, and also you can find from your class too. So practice, because we'll be getting one question from relative humidity, so for sure, so it's always better to be prepared. Right, let's get into the question. If you can do the question, just hold there, do the question and come back. Right, I'm going for the answer now here. Right, let's read the question. The initial relative humidity of a closed room of volume V. So it's always better to write down the values. Closed room and the volume is V. Temperature of theta naught is x%. Right, x is the relative humidity. Right, the temperature and the relative humidity of the room are then reduced to theta 1. Right, theta 1, and relative humidity becomes y% by using an air conditioner. Okay, certain amount of mass goes out then. Right, m dash. So if the absolute humidity of air at corresponding dew point is theta naught, okay, and theta 1 a naught. Okay, a naught is absolute humidity at dew point, and a1 is absolute humidity at dew point. Okay, then the mass of water vapor that has been removed by the air conditioner is. Right, so let's write down the equation for x. Right, so x equals current vapor mass. Let's say total mass of vapor is m inside of this thing, so I can write the equation like m divided by volume is the, so I'm writing the equation from absolute humidity because absolute humidity is given as data. So m divided by volume is saturated absolute humidity when saturated. So absolute humidity when saturated is actually equal to the a naught value here. So I'll write it like this. So it's a naught here. That actually then I can multiply it by 100. So this should be equal to x. Right, let's in the very same manner let's write down the second equation for y. So y comes actually m dash amount of mass actually goes out from the system now. So it's, let's write down from the same, m minus m dash current vapor mass that we divided by volume. So that becomes, yes, relative humidity, absolute humidity, and saturated absolute humidity is a1. So that I multiplied by 100. Okay, now remember they are asking us to find m dash. Right, let's simplify it furthermore. So I'll subject m here. From this one I can write x into, yes, a naught and divided by 100, and of course that becomes m over v, so I multiplied by v, so then m is this value. In the very same manner I'll get the answer for this one. So I get y a1 multiplied by v and divided by 100 equals m minus m dash. Right, so let's simplify furthermore. Right, now we need to find m dash. Actually m we have found, let's substitute this m from this value. Right, so let's write it now. So I can write y a1v divided by 100 equals x a naught v divided by 100 minus m dash. So m dash here, x a naught v divided by 100 minus y a dash v divided by 100. So I can, let's have a closer look at the answers now. Yes, x right? Let's simplify it furthermore. So I can write it like XAV minus YA 1V divided by 100. So that's our final answer. XAV not YAV not, yes, 100. It's the first answer, right? This is the answer now, right? So remember, we'll be getting questions like this from numerical values. Also we'll be getting questions. These are the 3 question types. So when studying, actually what you need to do it, you need to find graph questions and try similar type of questions, then move into statement questions, right? Then try similar type of questions, and then move into, yes, value based questions. So value based questions, actually you should go for numerical values and also, yes, symbol values questions. So I have only given you symbol value questions. So try these 3 type of questions, and there's a high chance we are getting a question like this for sure. So if you have practiced it, it's an easy 1 mark for you. So this is how we have to collect the answers, collect the marks for the paper. You have to fight for individual questions for sure. Alright, I have given you plenty of MCQ solved questions. Students, remember that. So just go through the playlist, you will find good questions. Cheers.